Okay, so this is Slope Fields 9.2, Video 2. So in the previous one, we kind of figured out how to sketch slope fields. In this video, we're going to have to go through some slope fields which are already created for us, and we have to basically be able to pull some information from them or determine which equation goes with which slope field. And that's kind of a common thing as well. So in this equation, a direction field for the differential equation y prime equals y times 1 minus 1/4 y squared is shown. So they're giving us that this is the slope field down here for that. Sketch the graphs of the solutions that satisfy the given initial conditions. So it just wants us to say, okay, if I start at, in this case, number 1 right here, if I start at y of 0 equals 1, sketch the slope field that goes with that. So first I'm going to find the point 0, 1 on my graph, 0, 1, which is right there. Now I kind of have to just follow the slope field. So again, stay parallel as much as you can. So it looks like going to the right, if I stay parallel, it's going to do that. And then all of a sudden I come across this what looks like horizontal dotted line there. So I have to basically stay parallel to it. So it's just going to kind of go off like this. Can't go any further. I can also go to the left. So again, stay parallel to these lines, parallel. And then when I get to the x-axis, now it's really hard to see there, but that is also a place where you've got dotted lines. There actually is a blue dotted line there. You just can't see it because the black line overtakes it. All right, number 2, y of 0 equals -1. So that is down here. When x is 0, y is -1, starting right there. So I'm going to stay parallel, parallel, and then it levels out. And then going back the other way, staying parallel, starting to level out, comes up towards the x-axis and then levels out. All right, number 3. Let's go with blue on this one. Let's do blue. Y of 0 equals -3. Y of 0 equals -3. That's way down here. This one's a little bit tougher because it looks like the slope field kind of runs off the page there. But if I go to the right, staying parallel, looks like it's doing this, and then it's going to start to ride y equals -2. And then it looks like these slopes, and there's not really any way for me to know this for sure, but it looks like these slopes are just going to go off in that direction. So I'm just going to kind of do that. And then the last one is y of 0 equals +3. So that's up here. Looks like it's a very similar idea as we go to the right, staying parallel. It's going to ride this like that. And then it looks like, once again, it's going to kind of go off in that direction. So that is sketching all of the initial conditions, or given the initial conditions. So again, as you can see, it's a family of functions. Okay, this is a family of functions. It just depends on which initial condition they give you as to what the function would look like. So if it was number 1, it would look like the green one. If it was number 4, it would look like the orange one at the top. So it depends on where the initial condition is. All right, and then part B says find all the equilibrium solutions. Okay, it might not be something that you've heard before, and I know we haven't talked about it in here, but the equilibrium solution is simply when the rate of change, or the derivative, is 0. So we are looking to find all the places where y prime is 0. Well, that's relatively easy to see because if your derivative is 0, everything is horizontal. So on our slope fields here, we are going to have an equilibrium solution when y equals, it looks like 2, when y equals 0, and when y equals -2. Those are our equilibrium solutions. So again, the equilibrium solutions are simply a place where the derivative is always 0. And that's it for equilibrium solutions. All right, one more. This is going to be a bit of a matching. And I will do my best to kind of give you what I look at to try and do these, because everybody comes up with their own way. So we want to match the differential equation with the direction field, and then give reasons for your answer. Well, again, I'm going to kind of give those to you as we go through, more verbally than anything else. I'll kind of try and point to what it is using the marker here as well. So let's see. We could do this in multiple different ways. We could do number 3, or we could start off with one of the graphs. So let's see, y prime equals 2 minus y. One way to think about that is that my slope is going to be 0 as long as y equals 2. Because if y equals 2, here I plug 2 in for y, I'm going to get a slope of 0. So let's see if is there any place on here where at y equals 2, the slope is always 0. And it looks like number 3 here, because when y equals 2, I always have a slope of 0. I do not see that on any one of these other graphs. Oh, nope, I take that back. Right there, y equals 2, the slope is always 0. So this might not be 3. Let me take that back. Let's see, what else could we figure out? Any value of y which is greater than 2 is going to create a negative slope. Because if I plug into y, if I plug in 3 or 4 or 5 or anything like that, you're going to get 2 minus those values. It's all going to be negative. Any value less than 2 for y, you're going to have a positive slope. So basically, I'm going to look at the upper half and lower half of these graphs and see which one matches. Okay, so if I look at graph number 1, the y values above 2 have both positive and negative slopes. According to this, they should only have negative slopes. So it does actually have to be number 3. Because if I look at also number 3, anything below 2, they're all positive slopes. Like every slope down here is positive, which makes sense because any y value less than 2 is going to create a positive value right there. All right, so that's 1 out of the way. Well, it might be a good idea to look for something else, because there's no other graphs that have horizontal slopes at 2. It looks like this one is also going to give us a 0 slope if y is 2. If we plug y equals 2 into that, we're going to get 0 no matter what x is. So I'm pretty sure that, well, I guess I should write this up there. That number 3 was number 3, ironically. Number 4 looks like it's going to be graph number 1. And again, it's because if I plug in 2 in for y, I'm going to get 0 slopes across the board right there. And then anything else, let's see. So if y is like 0, which would be down here, then it's going to be 2 times whatever the x value is. So if x is positive, you're going to have positive slopes, which we do. If x is negative, you're going to have negative slopes, which we do. So that one actually matches pretty good. Okay? You could probably tell by looking at the remaining 2 graphs which one of these things would be x plus y minus 1, which one would be sine of x, sine of y. The only one that looks like it's probably curved like sines and stuff looks like it's probably number 2. But again, we can double check that. So we know that if x is 0, sine of 0 is 0. So at x is 0, which is anywhere on the y-axis, we should have horizontal slopes. And we do. Everywhere up and down this thing. Horizontal slopes. If y is also 0, we're also going to have sine of 0 being 0. So that's also true, which is anywhere along, again, you can't see it here because of the fact that it's on the x-axis. So that is also true. So this definitely has to be number 2. And then that pretty much leaves number 5 to be graph number 4 here. But again, you can also kind of double check that. So if you were to plug in 0 for x and 1 for y, you would get out a 0 slope. 0 for x, 1 for y, you would get out a 0 slope. And we definitely have one right there. So that does check out. All right, that's all there is to matching. Good luck with that. Come up with your own ways.